So today we're going to talk about the change of base formula for logarithms. So this is really important because this is going to help us basically use a calculator in order to do um, any logarithm, in order to solve for any logarithm. But let's do some of what we already know, a little bit of a review, so kind of like a do now. So log base 2 of 4. So the question we ask ourselves is 2 to what power, right, is equal to 4? And I can write that here, right? 2 to what power is equal to 4? And the answer, of course, is 2 squared gives me 4. So I know the answer here is going to be 2, right? So log base 2 of 4 is equal to 2. So that's a question you're going to ask yourself for pretty much all of these. Log base 9 of 3. Now, the difference here between this problem and this problem, the first and the second one, is that going from log base 9 to 3, right? 9 to 3, you got to get smaller, meaning I'm going to take a root. And we know that, so again, we ask ourselves 9 to what power is equal to 3? And it's the square root, and the square root is the same thing as saying 1/2 power. So I know it's equal to 1/2. Now, on the contrary, this is a little different, right? It is getting smaller technically, but it's becoming a fraction. And so we know that when we're becoming a fraction, that it has to have a negative exponent, right? So 8 to what power is equal to 1 over 64? In order for this 8 to get in the denominator, I need to have a negative exponent. And 8 to what power gives me 64? 2, but it's going to be a negative 2. So I know this is going to be negative 2. Now, here is log of 100. We spoke about this a little bit, but this is really, really important. Log base blank is 100. So what is the base when it's log base nothing? So it's implied that the base is 10. It's just implied there because of the fact that, here, I'll zoom in a little bit. Log base 10 of 100. So then I can ask myself, okay, 10 to what power is 100? And it is 2. So 10 squared. But that 10 is redundant. We don't need it there. However, you can put it there for convenience, kind of just as a reminder, but you do not need it. Now, there's a few ways we could have done this problem. We could have done that. We could have rewritten it as log base 10 of 10 squared, right? 10 squared, that 2 can come up front so that it becomes 2 and then log base 10 of 10. Log base 10 of 10 is 1, so it just becomes 2. That's another way we could have done it. Another way we could have done it is using a calculator, right? Because calculators only have the option of doing, and I actually have a calculator here ready for us. Calculators only have the options of natural log and log, which is log base 10. So I could just do this equals 2, and it gives me the answer. So when you have log base 10, just a regular log, or a common log is what it's called, it is the most convenient because you can use a calculator, right? So here we have log base 10 of 28. So the question is 10 to what power is equal to 28? Well, nothing, no integer, right? So we go to our calculator and we just put log, we can just write it, log of 28 is equal to 1.447. So I'll put 1.5, 1.45. 1.45. What about natural log of e? So what is the base of a natural log? So here's your reminder that ln is the same thing as saying log base e, right? So this is the same thing as saying log base e of e. And we learned from our properties that when the base and this is the same, then these just become 1. So the answer is 1. And then last, for just a review, again, natural log is part of our calculator abilities. So I could have just went in here and put ln of e, and it would have given me 1. So here, when we have natural log of 312, I can put natural log of 312, and I get 5.74. I'll put via calculator. Every calculator and every scientific or above calculator has log and has natural log. Some more advanced calculators have like you can put log base 9 of 3. But most regular calculators only have log and natural log. So for that purpose, we are going to learn today the change of base formula. So what happens if the base is not 10 or e and it's not a clear-cut answer, right? So like this one. Base is 3, so I can't use a calculator, right? And then it's 3. It's asking 3 to what power is 15? Well, we don't know, right? 3 squared is 9. So 3 squared is 9, and 3 cubed is 27. So we know it's going to be somewhere in between 2 and 3, but we don't know exactly what it is. So today we're going to be using the change of base formula. Definitely write this down. Change of base formula. So if I have something where it's log base a of x, where a is your base, x is inside the logarithm, right? It is the same thing as saying it is equal to, you pick a base, it could be any base, and I have it written down here, and I'll move it a little closer, that b can be anything, but we probably want to make it 10 or e, right, for calculator convenience. So log base b of x, whatever x is, and log base b of a. And I'll show you what that means. Like if I have something like log base 7 of 2, it's equal to log base, I'm just going to put b here because it literally doesn't matter. Log base b of 2 over log base b of 7. Okay, so it's really important that we know that, okay? That we know that this is our change of base formula. But why? This makes no sense, Mr. Sood. Okay, great, you gave me a formula. What does that mean? And if you guys know anything about me, you know I don't like just giving you formulas and just making you memorize things. So I'm going to show you why. Yay! Okay, so if I have log base, and I'm going to color code everything for ease, log base a of x, right? That's what we have here. And I'm going to set it equal to y, right? Just because it's going to help us understand this. So equals, let's change that, equals y, okay? Now, if I want to rewrite this in exponential form, I'm going to do a to the y equals x, and I'm going to rewrite that. A, right here, a to the y power equals x, and I'm going to write x here because you'll see why in a second, equals x. Now I'm going to take the logarithm of both sides because the whole point of this is to change the base. It's called the change of base formula. So I'm going to pick a base, and I'm just going to say b for now because it could work with any base. So if I have log, I'm going to do, if I do it to one side, I have to do it to both sides. Oh, I'm going to redo that. So log base b of a to the y, and then log base b of x. Now, where can I move this y to? I know from my properties of exponents that I can move it up front. So I'm going to put y log base b of a equals log base b of x. And I'm going to solve for y. And so in order to solve for y, this is being multiplied, so I can divide this out. So I have log base b, gotta stick with my colors, log base b of a equals, oh no, I gotta divide it again, log base b of a. This cancels out. So now I have y equals, wait, y equals. Now, what did y equal to begin with, right? Y equals, whatever. Y equaled, oh, this thingy right here. So I'm going to say y equals this, copy it, paste it. Oh, that didn't work. Let's try it one more time. Copy, paste. Yeah, baby. Right? Y was equal to this, but now we also know that it's equal to this. So I'm going to copy and I'm going to paste that, and we're going to say it's equal to, oh, it's equal to this. And guess what? Here, ladies and gents, is your change of base formula. So log base A of x is equal to log base B of x over log base B of A, whatever A and x are. It looks the same. I got to zoom out to show you. Boom, boom. Same thing, baby. Boom. Okay, next, let's practice it. So this is the problem I gave you above, log base 3 of 15. So log base 3 of 15 is going to be, this is my, no, what color did I use over here? Red and then blue. So this is my red. This is my blue, right? So it's going to be equal to log base, whatever base, but I'm going to choose base 10 because that is the most convenient to do, or I could make it natural log. I'm going to do both. So log base 10 of 15 over log base 10 of 3. And now what I could do is now I can go here and I can say log base 10, so it's just log of 15, divided by log of 3. 2.4649. I told you it was going to be between 2 and 3. So this is my answer. So 2.46. Now, equals 2.46. Here's what I also want to show you. Let's say we did natural log. So we're making our base E. So natural log of 15 over natural log of 3. Let's see what happens on the calculator. Oh. So natural log of 15 over natural log of 3. Oh my God, crazy. It's the same answer. What kind of witchcraft? Okay, so 2.46. It does not matter. So what I want you guys to do is try this problem and try it out, see what you get, and then I'll go through it really quickly so that this video is not really long. So this is going to be log of 150 over log of 5. Let's stick with the colors. Log of 150 over log of 5. Now, again, I know that 5 to the second power is 25. 5 to the third power is 125. So I know it's going to be greater than 3. But it's definitely going to be smaller than 4. So it's going to be between 3 and 4. So log, let's try it out. Log of, what was it, 150 and 5? 150 over log of 5. 2.43. Told you. Wait. Oh, I put 50. I was like, that's not right. See? I was like, wait. You see how I noticed my mistake? I think it's really important here. I put 50 by accident. And so it said 2.43. And I was like, wait a second. I know it's going to be greater than 3 because 125 is 5 cubed. So I was like, something's wrong here. And I checked it. I typed it wrong. So it's 150 and it's 3.11, which makes a lot more sense based on what we know. So 3.11. Okay, lastly, because you guys have a Khan Academy that's similar, that has like problems like this. Which of the following is equivalent to log base 4 of m and log base m of 20, whatever m is? So what I'm going to do is I'm going to use the change of base formula. I'm going to do it right over here. So I have log base, I know log base 4 of m is equal to log whatever it is, just log, I'm going to use log of m over log of 4. And I know log base m of 20 is the same thing as saying log of 20 over log of m. So if I multiply, right, you're multiplying them. If I multiply these together, then I'm going to get log of m over log of 4 times log of 20 over log of n. And so now I have this and this go away, and I get log of 20 over log of 4. So what are my options here? So clearly that's not one of my options, so I got to keep going. Now, this, I can go backwards with my log, my change of base formula, right? So this, again, color coding, this is my blue and this is my red. So I know this is going to be my base and this is going to be inside. So it's going to be log base 4 of 20. And there's your final answer. Boom, baby. Thank you for attending my TED Talk.